Welcome. Today we'll be discussing two more examples of shifted standard sine functions, as well as being able to describe the properties of them. So here we have f of x equaling 2 sine of negative x. And we want to get it into the form of f of x is equal to a sine bx plus c, where a and b are positive values. So the first thing that we want to do from here is go, okay, how can we make the inside be positive? Well, we know that this is an odd function, so we could rewrite this as f of x is equal to negative 2 sine of x. Okay, that now makes b be positive. However, we still have this negative 2, so our a is now negative. How can we get that to be positive? And this is where memorizing the tables of the complements formulas, but in this case, the add pi formulas, we can rewrite this as f of x is equal to 2 sine of x plus pi. Because this plus pi, we can think of shifting this by half of a period. And so where there was once a peak is now a trough, and vice versa. So we take this, and now we want to describe what the amplitude is. Well, the amplitude is equal to our a, which is 2. Our frequency, and that is our b, which is 1. So that means our period is pi or 2 pi. It's technically 2 pi over b, but our b is 1, so that's just 2 pi. And now what is our phase shift? Well, it's negative c over b. So our c is pi. So we want negative pi divided by b, which is 1. So that's just negative pi. And when we want to find the base interval, we want to find the starting point of it. So starting point is just going to be our phase shift, so negative pi. And our ending point is going to be 1 period away from our starting point. So our period is 2 pi. So we're going to add 2 pi to negative pi and get pi. Therefore, our base interval is from negative pi to pi, including negative pi, excluding pi. And these are the properties that we are interested in. From here, we could also find the y-intercepts, all the x-intercepts, etc., increasing, decreasing, but these are the properties that we're most curious about. So for another example, we have this equation. And we want to say, hey, how can we solve this one? Well, the first thing is we need to get the cosine to be a sine. So let's first phase shift it. And so we can say that this is equal to negative 5 sine of negative pi over 2 minus 10x plus pi over 2. Pi's over 2 cancel, leaving us with negative 5 sine of negative 10x. We can use the same trick. This is an odd function because we're not phase shifted right now. So I can make the inside positive by attaching a negative on the outside. Well, I already have it being a negative, so a negative negative, and we get 5 sine of 10x. So now we have our A, we have our B, and our C is equal to 0. So we can say that our amplitude is 5. Our frequency is 10. So that means our period is 2 pi over 10, which is pi over 5. Our phase shift is 0 because it's negative c over b. So this also implies odd function. And now we want to find our base interval. So we want to find the start point. It is going to be our phase shift, which is 0. Our endpoint, we're going to add 1 period, which is pi over 5. So we're going to have pi over 5. And so our base interval is inclusive of 0 to pi over 5, excluding the pi over 5. For your check on learning in this video, please place down one of the 2 examples, your choice, and submit them for your check-in this week. Thank you for watching and have a great day.